At this point, we've learned the basic syntax of loops, and now I want to use loops to build an escape room together. So we're going to build this virtual escape room. It'll look something like this. You wake up, groggily look around, you're in some kind of escape room, press any key. Where would you like to look? So we're going to give the user the option to kind of explore a virtual space here. So they can go anywhere that they like. So maybe I'll go check out the door first. So I'll hit 4, check that out. I need a code. I don't know what the code is. Type in a number. Guess that was wrong. It takes me back to my sort of map or my navigation, and I can keep checking other areas. So I can check the cane. It's a walking stick. Blind person might use. All right. Weird that that's in quotes. Try the painting. Oddly enough, it's a giant painting of mice. You might think you think mice might be a clue. Okay, we've got mice and blind. We jiggle the drawer open and find a post-it with the number 3 on it. And hopefully at this point you've put it together that our clue is 3 blind mice. So I can go back to the door. Oops, you can see I made a typo there. So let's try that again. 4, 3 blind mice with no typo. There we go. And it's telling us we didn't do too well. It took over a minute to escape the escape room. But this is the general structure we're going to be building. We're going to be building this thing that's going to present a series of options to the player, and the player can explore them in whatever order. And like we saw here where I messed up, can repeatedly explore the same area if needed. And the thing that powers all of this, the thing that allows us to do this, is loops. So we're going to have a looping structure that keeps giving the player the option to explore the escape room. So we have 2 planning tools that we should use before we jump into this. So we've learned about flowcharts and UML. So our flowchart allows us to map out the branching logic of an application, the sort of procedural logic of that application, and UML is more about the data structures and our class structures. Where are we going to put things inside of our project? We don't want to throw all the code in one place. So let's start with our flowchart here. When our application loads, there was like an intro, so we can put that as the starting spot in our flowchart, where it tells you that you woke up groggy. And then from that intro, the player pressed a key and was taken to this kind of navigation. So we display options to explore. And we had the door, the painting, the dresser. Let's actually pull this back up. The painting, dresser, desk drawer, the cane, and the door. So those were our 4 branches. So this will be the door, painting, desk, cane. And these 3 interactions were pretty simple, right? When we went to the painting, we just saw some text that told us about what we were looking at. And then we pressed a key and we were back at our decision point. So we can display clue in all 3 of these boxes. And all 3 of these take you back to displaying the options to explore. if the player chooses the door, the logic is a little bit different here. There's a little bit more interaction. So we saw that here. When we step up to the door, we need to enter a code. So then it waits for the user to enter a code and then checks whether that was right or wrong. So if you get it wrong, you get this message. And if you get it right, you escape and tells you some info about your score for escaping the room. So this prompt for door code. We have 2 branches off of this. Code was wrong. Code was right. If it was wrong, we have to tell them that it was wrong. So display wrong feedback. And then we take the player back to the exploration option. Ooh, that's an ugly line. Let's try that one more time. Slightly better. And then if they got the code right, then display right feedback. And then we take the user to the game over, the win screen. So there's our branching logic. And you can see in our flowchart the kind of cyclical nature of things, that we have the ability to explore these options, and these options take us back to exploring again. So we're going to have a loop around here in our code with one possible way for the user to escape that loop, to actually get the door code right, and then they are out of our escape room. So this flowchart helps us map out the branching logic and the cyclical logic in our code, but it doesn't help us map out what classes we need. So it's good to do both of these before we even touch any of the code. And one challenge that I would throw to you is like pause the video before I actually write out these planning tools, see if you can figure out a structure on paper, and then kind of compare with what I'm doing in the video. So for UML, the way that I recommend thinking through this is trying to divide up your application into classes that have single responsibilities. So in our game, just thinking about what we've seen here, we kind of have these room objects that you're able to explore. Those seem to be pretty similar in terms of their functionality here. All of them just display some information when they are explored. So that's probably one class. Our door is a little bit different, right? Because it has this interactivity. So I think we'll need another class for that. And then if we think about this whole application running, we need something that's doing this logic of sort of orchestrating the whole flow of our escape room, which would be giving the user the ability to choose where to explore, and also doing things like tracking how long it took them to escape. So for our UML, we might have escape room a room object, so like the painting, the cane, the desk, and the door. This isn't the only way to structure this application, and kind of as we build on this structure, if we decide to take this forward, we might have to refactor this structure, but the classes that we've identified seem like they match with the functionality that we're seeing in our application so far. So after we have figured out what our general classes are, we then want to fill in the attributes, so the pieces of data associated with each class, and the operations, the methods that each class might have. So let's take a look, starting with our escape room here. So our escape room is going to need to orchestrate the flow of our application. So it's actually going to need a couple of room objects, one for each of our things that we have to explore. So we'll need the cane room object. We'll need the painting. We'll need the, what was the third one? The desk drawer. And we'll also need the door. And if we decide to build in that score feature that's based on your time, we'd also need some place to track that. And as far as our operations go, we'll definitely need something that starts the escape room, and we'll need a constructor. So let's throw the constructor here, escape room, and we'll also need something like start room, which we can use to kick off the logic of the room. And we may break this down into a couple more operations as we actually shift over to code, but this should be enough to capture the fact that our escape room is kind of our manager. It's responsible for the flow of the player getting to interact with these objects and trying to escape. So then our room object, I lost my console window. There we go. Our room object has to have kind of a name for us to display here, and then has to have a description. And maybe we'd also want the color, because in the version that I've set up here, each room object is a separate color to help make it distinct in our escape room ASCII art, our text interface here, to make it a little bit easier to navigate and differentiate between the objects. So we'll need the name, and we'll need a description. And then if we decide to add color, we'd also need that here as well, and we would store that as a console color. So the operations for our room object are pretty simple. We'll always generally want a constructor with our classes, so we can create that here, room object. And when we make this room object, we're going to want to pass in the name, the description, and the console color. And then the main interaction with the room object is just getting it to display itself. So when the user chooses painting, this name and description should be displayed in our console window. So we could call it display info, display clue, display description, something along those lines. All right, last class here to map out before we start coding. If we think about our door, it has this code associated with it. So it needs to keep track of that code. And it also looks like we're displaying it in a particular color. That might be useful to hold on to as well. So our door has a code, and because this is something the user is typing in with read line, it's going to be something we store as a string, most likely, and maybe also a color here. And like with our room object, we'll want a constructor so that we can make instances of this door class easily with a code that gets passed in and a color as well. And then the main interaction that we have with our door is this escape logic. So we type in something and we're attempting an escape, and it either is a success or a failure. And if we're thinking about the responsibilities of our classes in the context of this flow, our escape room is the thing that's going to keep us in this cycle. It's responsible for looping, displaying these options to us, and then having the door, painting, desk, cane respond when we choose those things. So we need some way for our door, when we do this prompting, to communicate back to the escape room to say, like, hey, the attempt escape was a success or it was a failure. So our door is going to have a attempt escape operation. This is going to run the logic of asking for the code, reading it in, and then it is going to return a Boolean back to our escape room so that our escape room can decide, if true, hey, they escaped, great, we can move on to the win screen. False, we can stay in our loop. So I know when you're starting out programming, it can be hard to think through the flowchart and think through the UML without doing any code. But hopefully this process gives you a scaffold in your brain for what we're going to build. And then you can revisit what we talked about here after we write the code or as we're writing the code to help see the connections between what we planned on paper and what we actually implement in code. So what I want to do now is open up Visual Studio and create a new .NET Core console application. Going to make sure that I store this on my computer with my other files, and I will call it Escape Room Game. And remember our process for making larger, I'm using quotes here because large depends on, where you are in your programming career. But when we're working on these complex applications in Intro to Programming, you want to build one small piece at a time, test, and then repeat that process. Build the next small piece, test, and then repeat that. That way you're getting your project working with new features each time, solving errors as they come up, which will help you stay motivated and will also help prevent the situation where you go to hit play and there are 500 things broken and then you spend hours debugging before you ever see anything work. So first thing that I want to do, looking at our chart here, is I'm going to start with the escape room, and I want to get this start room method working. So I want our application to start the room and maybe just like really simply display that first message about waking up groggy. So I can clear out the console write line from my main function, and I can add a new class. And I'll call it escape room. And I want to create a public void, meaning it doesn't return anything, method called start room. And this should do our printing out of our initial message, and then let's do a read key to make sure that the window stays open. So we will using static system.console up here so that we don't have to say system.console.writeLine. We can just say writeLine. Let's do a writeLine. You wake up. You wake up and groggily look around. WriteLine. Press any key to exit. Read key to keep our console window open. So if I hit play right now, nothing's going to happen because we've created our start room method. We've defined the start room method, but we never invoked it anywhere. So what we need to do is head back to our program, create an instance of the escape room class, and then myroom.startRoom here. Whoops, forgot the new keyword. So instantiate a instance from our class, from our blueprint, and then with that instance, we can call our start room method. And we made sure to make this method public so that we could access it here from our main method. So there we go. First small feature built. We got an intro message showing up. While we're at it, let's change the title. And let's add in here our message that says that looks like you are in some kind of escape room. So here I'm just adding a pause after our intro before the next thing kicks off in our game. So I read that, I have a chance to process it before I press a key, and then the next thing happens. And right now that next thing is that we end up waiting for them to press a key to exit, but in the full context of the game, that would be like, let's present the first choice to them. And when we do read key like this, if we pass in a value of false here, the parameter here, bool intercept, allows you to control whether that character that's pressed actually shows up in the console window. So false, I think, is the default, which means that it does not intercept. So if I press 1 here, we can see 1 showing up. But if I type in true here and here, that should prevent that character that's typed from actually showing up in the window. So I'm pressing 1, nothing shows up. So that'll give us a cleaner user interface. Great, so we have our escape room started. What I want to do is get our room object created. We can pretty much build out all of this class and test it before moving on. So we'll add a new class here. We'll call it room object. We said that the room object needs a name and a description and possibly a color. I think for this first version, I'm just going to do name and description. Public, string name, public string description. We said that we'll want a constructor here. So this is a method with the same name as our class. And then we will pass in the information to construct or initialize our fields here. So we've got name and description. So we'll want to take in a name and description variable so that we can then apply it. So with this, we should be able to create a room object. So if we flip back to our escape room and we create a field up here. So this is going to be a private field for our, I guess let's start with the painting. So this is going to be a room object called painting. And then in our constructor for the escape room, so when we call new escape room from program, we want to construct that painting. So painting equals new room object. We pass in the name and description, which I believe was something like the name is painting. And the description was something like it's oddly enough a giant painting of mice. You think mice might be a clue. So just zooming out so you can see all of that, and I'm using the escape sequence here to make sure that mice has quotation marks around it when the user interacts with this room object and sees the description. So right now, we have our painting created from our room object class, but we haven't done anything that would be observable to us. So the reason why I did this was just to test that our constructor was not giving us any errors. So we don't yet know whether the room object does what we want, but it does not prevent us from running our application. So we kind of have a little bit of validation that we set this room object up correctly. To see something happen, we can build our next feature, which is we want to make sure that if we tell our room object to display its information, that it goes ahead and does that. And once we have that display info method, we'll be able to use it and actually see the painting. So we'll be able to verify that everything, the name and description, are actually working. So here's our display info method. It is public because we need to access it and run it from escape room. It's void because it is not going to return anything. It's just going to display something to the screen. And it takes no parameters. It doesn't need any information. It's just going to print out the name and description. So we can say, right line, you inspect the and we're going to put our name variable in here. So I need to convert this to string interpolation and then throw brackets around the place where I want the name variable to be inserted here. And we will right line the description below that. And then we can right line, press any key to continue, and read key with an intercept of true so that whatever they press doesn't show up. And what we've got here is I am calling these methods without the fully qualified path. So I'm going to come up here and say using static system, system.console. So I've got my method defined for display info. So I can come back now and we can call display info on our painting after our intro message here. So hopefully that will display both the name and the description. You inspect the painting. It's oddly enough a giant painting of mice. You think mice might be a clue, and we get our press any key to continue, and then we're at the exit. So all we have to do now to finish up our room objects is create the other instances. So we had a cane, and we had a desk drawer. I'm going to copy and paste this painting line and start replacing the information here. So we've got our cane set up to be a new room object, our desk drawer to be a new room object. Let's change our names here to cane, desk drawer. And then for cane, let's replace the description. You realize it is actually a walking stick that a blind person might use. And our desk drawer description here, we can replace. I'm going to zoom out so more of this fits on the screen while I'm typing. It sticks slightly, but you manage to jiggle it open. You find a post-it with the number 3 on it. So all of our descriptions have these quotation marks around the thing that we are trying to highlight for the player. You could do something more subtle, like change the color of the word. You could omit those if you want to make it even harder for your player. So let's test it out. Let's have our painting display, and then our cane display, and then our desk drawer display. We're groggy, we wake up. Here's the painting. We inspect the cane. We inspect the desk drawer. And then we're out of the game. Right, so looking back at our whiteboard, we have our room object basically done. We can come back and add in the color later if we want. So let's move on to the door, where we will ignore the color again, but we need to make sure that the door stores its secret code and that it has a method that allows the player to try escaping. So I'm going to add another class here called door. It's going to need a private string code. Private here because no one else needs to access this. We only need it inside of the door class. Same with our objects. Whoops, I made these private. I made these public, so these can be private. No one else needs these. Head back to our door here. Let's create our constructor, which takes in a code and then uses that to initialize our code field. And then we will create our bool attempt escape. And remember, this is public because we need to use this from our escape room. This is the thing that's going to control whether we get outside, whether we are able to leave our loop. So with our attempt escape here, I'm going to need to do some console stuff. So I'm going to bring in system.console. We can print out something like you step up and try the door. It's locked and needs a code. And don't worry about this error. If we hover over it, it's just telling us that, hey, you said you returned a bool, but your method doesn't return a bool in all situations. We don't return anything, so we'll need to fix that in a second. Here we can write instead of write line so that the user ends up typing right here after our prompt to enter a key or enter a code. And then we can get the player guess equals read line. So we're going to get whatever they typed in. Let's also use our to lower and trim to remove the white space from the beginning and start and convert it all to lowercase so that it's easier for us to compare it against our secret code up here. If the player guess was equal to our code, then we know that they are able to escape, so we can print out something like click, the lock fell, lock falls away, you escaped. Otherwise, right line, nothing happened. Guess the code was wrong. And let's do our press any key to continue. Read key false, or read key true. And we can do the same thing here. So what we want to do after we determine whether they were right or wrong is return true in this situation. You know, they attempted the escape and they were correct in the code, so they can get out. Return false here if they got it wrong. So let's test this and make sure that it works before we move on. So we got a fair chunk of logic written here with our door, our constructor, and our attempt escape method that gives us back a Boolean. So if we head back to our escape room, we can create a door instance. Let's call this the locked door. We wouldn't want to call this door because our class is named door. So I'm going to call this locked door. And our locked door is equal to a new instance of our door class. And our code we pass in here, 3 blind mice. And I'm passing it in all lowercase, which will make it work with our lowercase detection of what the user typed in. So we can run our method that we just created, and let's also capture whether or not they were successful into a Boolean variable. And then we can write line, did they escape? And we'll print out our Boolean variable here. So let's try getting the code right here. So we're seeing all 3 clues. Let's try 3 blind mice. Lock falls away, you escaped. And then we can see that our escape room knows that they escaped. We got that true value back because we returned it true. And if we do this again, and let's get it wrong. 1, 2, 3, 4. Nothing happened. Guess the code was wrong. And our escape room knows that they failed. So the key thing that we're doing here is communicating between the locked door here, this check. So we want to know, did they get it right or wrong? And we're returning that information. So that's how we're able to communicate something from our door back to our escape room. So one thing that we can do now that we've written this out and got it working is actually refactor this. So we're doing some repeated logic here and here. We could just grab this, move it down here, delete this, and instead of returning true, we can just return this, which we know that our equality check turns into a true-false value. So no matter what happens with our if, we will always say, press any key to continue, we'll wait for a key to be pressed, and then we will return whether or not they were right. So a small refactoring just to cut out some duplicated logic. This should still work the same. I should still be able to type in 3 blind mice and escape. All right, we have all of the basic pieces here. So we've got our door done, our room object done. We skipped some of the user interface stuff like the console color, but that's fine. We've got the functionality working and we verified it. So the last thing we need to do is return back to our escape room and think about the flow. And we'll bring in our looping structure. So we'll display those options. We will check which they picked and then direct them to the appropriate object. So whether that's one of our room objects here or that's our door instance here. So if we head back to our escape room, we don't want to just do this, but I will comment it out and leave it here for reference for us to refer to. What we want to do is ask them like, hey, what do you want to do? So we need to tell them let's use a different thing. I use equal signs a lot. Let's use some tildes here. So we're printing out our navigation menu. So right line, where would you like to look? And then we can right line the options. So I'm going to print these out with 2 spaces before each of the options. Three, a cane, 4, a door. So this should print out a little separator so that it separates out this text from the previous text. And then each of these should be displayed on a new line with 2 spaces so that this all seems indented over from our question here. So let's check that out, see that it's working. Where would you like to look? Good. Let's actually add some space here so that everything isn't so cramped. All right, that's looking better. And wow, that was perfect. It lined up exactly. I didn't mean for it to, but it did. Let's get their choice now. And we can call this navigation choice, where we're just going to read line whatever they typed in. We're going to do our same trim that we've done before. And since they're typing in numbers, we don't have to convert it to lowercase. There's no such thing as a uppercase 1 or lowercase 1. So we can just do our trim. And then let's also print out this afterwards. And for testing purposes, let's check out that navigation choice. So we can see you chose. Where would you like to look? 1, you chose 1. And we can actually take our read line here and, oh, you know what? Let's leave that alone. This is fine. This chunk of logic actually would be nice as a method that we can separate out from the start room method. This will help with making our code a little bit more legible because we're going to break our start room method into some smaller methods. So here, let's create a private method because we only need it internally, and we can call this navigate. And we want it to return the choice. So we can grab a string or grab the string type and put it here. and then grab all of this and return our navigation choice here. Choice equals navigate, and then we can use this local variable choice here. So nothing should have changed. We've just refactored that chunk of logic to tuck it away into a reusable method. So we still see our choice being printed back to us. So now what we want to do is set up our looping structure. We've got our choice, and we need to, based on what they pick, send them to the appropriate object, and then repeat this process of displaying options for them to explore and letting them navigate, check out different objects, repeat the process, etc. So we need a loop here. So we're going to create a field has escaped. When our game starts, we'll set up has escaped to be false. And then what we want is a looping structure. So while not has escaped, remember that not takes a Boolean value and flips it. So if has escaped is false, that means our condition is true. So it's going to keep running as long as has escaped is false. At the beginning of each iteration of the loop, we'll let them choose, where do you want to go? And let's test this out. This should give us a loop that runs infinitely, but constantly lets you choose. So we've got, I want to choose 1. Now I want to choose 2, 3, 4. What if I try 5? It spits back 5. So we've got our structure for the loop here. Now we can go ahead, and instead of saying you chose choice, we can say if choice was 1 as a string, then painting.displayInfo. Else if the choice was 2, then what did we say? Desk drawer was 2. Choose 3. We said that was the cane. And else if choice was 4, that should be the door. Attempt escape. Whoops, we called that locked door. Attempt escape. And if they did not pick 1, 2, 3, or 4, we need to tell them, like, hey, that was not right. So actually, I'm going to break this out into a reusable method. So we can say this is a private method that doesn't return anything, and it's just going to display invalid choice feedback. Right line. That's not a valid option. Try again. And we will do our right line. Whoops, forgot a semicolon. Press any key to continue. And wait for a key to be pressed, and we will intercept that. So now we can use that method here. So we should be able to explore multiple things. We can't get out of this loop yet, but we can test 1, 2, 3, 4 and doing something invalid. We chose 1, inspect the painting. Here we get the desk drawer. Inspect the cane. Asks us for the code. But even though it tells us that we escaped here, our escape room doesn't know that, so it's just going to keep presenting these options to us. Oh, and actually, let's test our invalid choice now that we've got that built. So type in a bunch of gibberish. That's not a valid option. Try again. We can get rid of our right line that we were using for debugging purposes. And the last thing that we need to do is figure out how to connect the attempt escape method. Remember, it gives us back a Boolean here, was successful, to our loop structure so that we actually get out of the loop. So if we capture what was given back to us from locked room, we can set that here. So whatever true false value we're given, let's change has escaped to be that true false value. So if it's true, that means that our next iteration of the loop, our condition is not met. Not true would give us false, so our loop structure won't run. Or sort of reading this in English, this loop runs while we have not escaped, and as soon as we have escaped here, as soon as has escaped is true, we're done with our loop. So that means that our intro goes up here, and then our win code can go down here. So we can say like right line, congrats on escaping. Thanks for playing. And if we wanted to do that kind of feedback about how well you did based on your timing, we could also print that out down here. So let's test that, see that it's working. Press any key. Let's go straight to the door. Let's try the code. Lock falls away, we escaped, and then it prints out our congrats on escaping, thanks for playing. And I think I want to add a new line here so that there's some space. But generally that's working. It's good to also check what happens if we get that code wrong to make sure that we stay in the loop. So go to the door, type in something that's wrong, and we're still stuck in our looping structure. So zooming back out, we did it. We got our escape room working here. We were able to plan this out with a flowchart, plan out all that branching logic, all the cyclical logic here. We used our UML to try and divide up our application into logical classes that each are responsible for one thing. Room object just responsible for displaying the information about that object. The door just responsible for holding on to that code and letting the user try to guess that code. Escape room responsible for the flow of the overall game, making sure that you're displayed the options, and when you escape, you get like your nice win message. So I'm not gonna go through the process of adding color to this, but if I run my version over here that has color, you can greatly improve our user interface here by making our painting and our desk drawer and our cane have their own color. And same with the door, improve that so that all of these elements stand out in our text-based interface. And if you want a bigger challenge, you could try adding some ASCII art to each of these. Go find some ASCII art of a painting and a desk drawer and a cane that you insert into those room objects as well. So that's all I got for you. I'll see you in the next video.